Welcome to EDU World Space.
So this problem, for the cannonballs, we will let subscript A refer to the 12 kg cannonball and subscript B to the 18 kg cannonball. Now the motion of the mass center of A and B is uniform in the x direction, uniformly accelerated with acceleration g is equal to 9.81 meters per square second in the y direction and 0 in the z direction. So let's find each component of the motion of the mass center. So the x component, x bar, is equal to v naught in the x direction times time t, and this is equal to 165 meters per second times a time of 1.5 seconds. And hence we get the x position of the mass center to be 247.5 meters at a time of 1.5 seconds. The y position of the mass center is equal to the initial position y naught plus v naught of the mass center in the y direction times time t minus a half gt squared, the term due to gravity. So this is equal to y naught, its initial height, 15 meters, plus its initial speed in the y direction is 0, minus a half into g, which is 9.81 meters per square second, multiplied by time t, 1.5 seconds squared. And hence we get, after a time of 1.5 seconds, the center of mass of the system is at 3.964 meters. And the center of mass, the z component of the center of mass, z bar, is equal to 0. So therefore, the center of mass vector r can be written as 247.5 meters times unit vector I plus 3.964 meters multiplied by basis vector j. So now we have the position of the mass center after a time of 1.5 seconds. And using the definition of mass center, we know that the mass of the system, which is the mass of the two cannonballs, times the mass center position, is defined as the mass of fragment A times the position of fragment A plus the mass of cannonball B times the position of cannonball B. Now, with our data from above, our masses and our positions, we can write down this equation by substituting the values. So the mass of the two cannonballs is 30 kg, and the position of the center we calculated to be 247.5 I plus 3.964 J, and that's equal to the mass of A, 12 kgs, into the position of A, which is 240 I plus 7 K. So that's 240 in the x direction and 7 in the z direction, plus the mass of B, which is 18 kgs, times its x position times unit vector I plus its y position times unit vector j plus its z component times unit vector k. And so if we solve this component by component, we get the following. For the I component, we get 30 into and 47.5, so we're equating like components, is equal to 12 times 240 plus 18xb. For the j component, we get 30 into 3.964 is equal to 12 times 0 plus 18 times yb. And finally, equating the k components, we get that 30 times 0 is equal to 12 times 7 plus 18 times the z component of b, zb. And so from here, we get the position of cannonball B after a time of 1.5 seconds as follows. The x component is 253 meters. The y component of position, yb, is 6.61 meters. And the z position is minus 4.67 meters.